you see here, well, I haven't put it down yet, but, I started this too early. I started this video too early. I need to put the triangle. Okay, here's the triangle. It's not filled in yet. And then, you probably don't understand, but you've read the title already, so I'd expect you to understand what this is. Mostly because of the facts. Mostly because of the fact that it's understandable.
You still got a Coke? Or you want milk?
I'm recording. Okay, there. So you see here, this triangle. If you recognize this, you probably don't. But this is the rock, paper, scissors triangle, like the Pokemon type triangle. And you see something peculiar about all the things that they have in common. You might say, how does a rock, a paper, and a scissor have in common with a green dinosaur, a water turtle, and a fire lizard? Well, what they have in common is they have a tight triangle. You say, this is rock, which is bad against this, which is paper, because the cyan is good and the red is bad against. And then this is scissors, which is good against paper but bad against rock. You can also do this with Bulbasaur, which is good against Squirtle, which is good against Charmander. And you notice here, it works exactly the same way. They each have compatibility with every other thing in the triangle. This one has compatibility with this and this one, which is the other two. This one has compatibility with this one and this one. Then this one is this one and this one. You get the point. But what would happen if I suddenly... Well... add another type to the triangle. This is important because you'll see and then we add the cyan into the triangle. And you notice anything wrong with this square formation that wasn't wrong with the triangle? why would this be wrong? But this be right. Well, it's because of why. It's because of why they pick the triangle. If you go down to the reasoning of why they pick the triangle, then you'll see an answer that actually tells us our answer to this other question of why did they pick, or what is wrong with the square. You see this. They picked the triangle. Let me rehearse this. Because everything has a connection with the other. You see this perfect circle here? It works. There's no other circle, or there's no other line to be made here. There's no other line because everything is already being compatible or non-compatible, or everything is already touching each other. Because, you see, the way this works is that there's a super effective, a not effective, or a good against or bad against, like with rock, paper, scissors and the Pokemon stuff. But because there's 2 things and 3 triangles, and since it doesn't have to have a connection with itself, that means it counts it as 2 things, 2 connection ways in 2 other circles. And that makes it to where it works very well because everything is compatible. But if that doesn't answer the question, here's this. You see, this can go to this, right? They can go to each other. This can go to this. This can go to this, and this can go to this. But this doesn't go to this. And this doesn't go to this. And that's why they picked the triangle, and that's why the square is wrong. So, how to fix this problem? Well, to fix this problem, we need some way of adding a new way to interact with something else. You might be wondering, why can't you just add one more of the same, I'm just going to be calling this laser types from now on. Why can't you just add more of the same laser type? Well, in theory, like when you first think about it, just the first thought about that, it might seem right. But here's why it's wrong. It is wrong because if you had 2 damage points here, had a damage point between here like you have a damage point here. So oh yeah, that wouldn't make sense because it's not even. If you have 1 damage point being more, or you would have 1 damage point being more, and 1 good point being there. This one, it wouldn't work for this because of the fact that it wouldn't be even. It wouldn't be fair for them because they would have two different types. Or not two different types. Two different things that can damage them, but only one thing that it can damage and do a lot of things. And for this one, it would be too overpowered because you see how it would have two different things that it can damage, but only one thing that damages it. So that is where neutral. That's where neutral comes in. Might be wondering, what does neutral even do in something like this? Well, neutral means that it isn't super effective or non-effective. So they do the same amount of damage to each other. And this helps a lot. You'll see. Because now, if we have neutral in here, if we have neutral, and we have neutral here, and then we'll see how this point has one thing that it can damage, and one thing that damages it. But because of the neutral, it has another thing that can damage and another thing that damages it with the same thing. So that's one line that compensates for both. That also works with this, and this, and this. All different things in the type square need that. So make sure to connect all your diagonal points with neutral. Again, we don't need neutral here because everything is already connected to each other. What happens when we get a more complex shape? Like, what about a shape like, well, what's the thing with 5 sides called? A hexagon, I think. What if we get a complex shape, or a more complex shape, like, no, it's pentagon, hexagon, no, it's a pentagon. A pentagon is the shape that I'm thinking of. So, we see this very complex shape. How would neutral work with this one? How many neutrals do we need? Now this is getting to the part where I haven't thought about before making this recording. But let's just connect all the dots. So, now we have it to where it has two things that isn't connected. So, easy problem. Just have two neutrals. And if you'll notice, having the neutrals here actually makes a star, which is a really cool fact. You see, there's no neutrals here, so it makes nothing. This one makes an X, and out of nowhere, this one makes a star. It's really neat. You'll see how this connects all of our dots together. And This works with every single shape. Every single amount of points that you will have works with neutral, except number 3, and the number 2 and number 1 don't work, because number 1 won't have anything that it can do good or bad against, and number 2 won't work because because you can't do good and bad against the same thing. That's why we don't have it to where, well, let's just demonstrate. This would be bad at the same thing and good at the same thing. And even if you made it to where half of the lines is demonstrated as good and half of it is demonstrated as bad, you still have it to where, well, this is good against this, and this is good against this, which still wouldn't work. The same goes with the bad side. So that's why 2 or 1 wouldn't work. 3 is the minimal that you can get. Just like with polygons. Neat. Anyways, so now we try our way with this. Let's just go up.
I figured you were going to go off the wall, so I took it slow.
So we have so far a triangle, a square, and a pentagon. I'm pretty sure that's what it's called. Right? Yeah. Oh no, it's a pentagon. Gone. So now let's try this with... what? That just glitched.
Oh, it moves.
Let's try this with an even more complex shape. And you'll see how this works exactly how it did last time. Except for the fact that it just adds 1 more neutral. That's the only change. It just adds 1 more neutral. So 3, you'll see here, 3 neutral. Because it's only connected to 2 of them. So there's 3 here that it needs to be connected to.
Jones, you see that? I smoked his ass, Jones. Jones, talk to me, Jones.
And this makes a shape that doesn't really exist. That's where the shape thing here kind of gets, well, boring. It was cool, because all of this here, the first 3 were cool, but as you get to, like, hexagon, it's kind of boring, because the first one, it's cool because it doesn't have a neutral and it's familiar. The second one's cool because it first adds a neutral. And the third one's cool because it's a star, but this one, nah. So we need to develop a math equation for this, because I want to. So a math equation for this. you'll see how adding one more point adds one more neutral for them to use. It adds every single point added adds one more neutral for each thing to use. This one has 0 neutrals and it is the minimum. Adding one more makes it to where there's one neutral that you're supposed to use. Adding another one makes there 2, and adding another one makes there 3. So, since you can call these dots what you want, this is the equation. I'm only in 4th grade. I don't know how to do math exactly, but I'm pretty sure this is what it is. Plus 1x equals plus 1y. It sounds crazy, I know, and I might be just failing at this. This might be crazy, but the x would be the points. At least in this equation, you can call it what you want. And the y would be the neutral. And coincidentally, points doesn't have x in it, and neutral doesn't have a y in it. So, to summarize, this is what we have here. We have the triangle. Actually, I should probably add in the stuff that the first two that just don't work. Yeah, I'm gonna add that in, just to fill more space. So you start with 1 dot. That does good and bad to itself, which wouldn't work. So we mark this one with a green X because I needed another color and green's my favorite color. We also have the number 2. Which the thing is here, this does good, this does bad against this, and this goes good against this, but this says that it does good against this, and this says it goes bad against that. And even if we took away this bottom spot here, then there would be nothing for this to be good against and nothing for this to be bad against, so it would be unfair. So again, green X for you. So, to summarize, we have 1 dot equals no. 2 dots equals not at all. 3 dots is where it starts actually working, but there is no neutrals here. Actually, 2 could actually work if you had a neutral. So actually, I'm gonna mark it with an X. Because green means definitely not. And yellow means plausible. Actually, no, I shouldn't mark that. I was wrong. Because I didn't do that for, like, square and stuff, so, yeah. So, yeah. So what we've learned is 1 dot is the only amount of dots that doesn't work. Well, 0 dots doesn't work either, but it's 0 dots. 2 dots does work, but only with neutral. 2 dots does work, but only with neutrals. Triangle does work, definitely. And it's the only one that not the only one that, it's the only one that doesn't have neutrals that actually works. This, you had to add 1 neutral. This, you had to add another neutral. This, you had to add another neutral. It works infinitely. But now, with this system, our thing is kind of flawed. Our math problem is kind of flawed. So let's think about this. What if we do What if we do this? This will make it work. So, So this is how we make our math problem work. That's how it would work. But below, this, you have +1 times 1.
Yeah. They had the crowds.
+1 times 1. Then subtract 1. I forgot to add the x's in there. +1 x and plus 1 y, which we've already established what that is, times 1. And then after that, and then if you add plus 1 point again, then it subtracts 1. And this is our perfect equation. This is totally our perfect equation. No mistakes here. So yeah. This is me overreacting to a children's game of rock, paper, scissors. Goodbye.